It sounds easy.
Yeah.
But then when you go to it, like, oh, no, I can't do this.
Sure, we're gonna have the same thing.
Yeah. So you go to window. Okay,
How about
so
this?
yeah,
Y
that's right.
equals
And then so we went
2x to the
here.
fourth
This is
minus
gonna be
6x
0, and this is
squared
gonna be
plus
120.
4. And I want you guys to find the critical values and tell me what they are, the maxima, minima, or points of inflection. So the first step is find the derivative. So 8x cubed minus
Oh, that's
12x.
what you did. So this is, remember, this is gonna be negative
Set it equal to 0 is
Oh, I
8x
see.
cubed minus 12x.
And then
This is not easily factorable, is it? So instead of trying to factor this and figure it out that way, I'm going to graph the derivative. You graph this,
Oh, okay.
okay?
Then you find the point that
The points where it
You got
crosses
this,
the
like,
x-axis.
Don't overthink it.
So go to
that's
your
what it is.
y,
That's what we just found.
and then we enter that 8x cubed minus 12x.
Yeah, of course.
8x cubed minus 12x. And
Wait.
I'm going to graph it.
I'm sorry, I missed a little chunk of that.
So-
Can you start?
We're looking at
You said critical values is what you're looking
Yeah,
for.
we're
but you
looking for
can't
critical
factor it
values,
out.
but it's not easily factorable.
Okay.
So instead of factoring it and messing with it that way, I'm gonna graph it. So
Okay.
I
The
know,
first derivative.
I know there's gonna be at least 2 solutions, possibly more,
Right.
because of the power of this, right?
Right.
So I'm gonna look for 3 places where it crosses the axis. So I'm gonna go back to my standard, so I can go to zoom standard
Second trace.
and
Or,
see
sorry,
what
zoom.
happens. So remember, I'm graphing the derivative here. I'm not graphing the original function. So this crosses 1, 2, 3 times. So I want to zoom in on those points. So what am I going to do to my x min, x max, y min, y max?
Wait, you wanted to find.
I want to find those 3 x values. Wherever it crosses the x-axis is where the slope is 0.
So you have to zoom in,
Yeah, I got to zoom in. So what am I going to do to my window?
shrink it.
Shrink it, yeah. Maybe -3 to 3 on x. And I don't need much in the y, I just need enough on the negative and the positive sides so that I see it cross, right? I don't need the entire graph. So if I hit graph, all I care about now is that point, and that point. Those are my critical values, because that's where the slope is 0, slope is 0, slope is 0. You guys with me?
say that again, sorry.
So I only care about these 3 points because those are where the slopes are 0.
Okay.
Can you show just one more time how you got here, which
Yeah, that's
is
good.
that fine?
That's good. Sure, of course it is. But if you want a little more detail, get in a little bit closer. So you can change your x min and x max to be just a little bit
Okay.
closer to 0. Right, so you can get a little more detail. So remember how to do this, guys. We're going to go second trace, which is calculate.
Value.
We're going to arrow down to 0, hit enter. Now let's take a look at this first one over here. So it's questioning, it says left bound. So we want to drop the cursor a little bit to the left of the point we care about.
So you're
Right.
just doing the minimum.
No, not minimum, left zeros.
Like right here? Or,
No, we care about these 3 points,
okay.
not the minima. So when I set my cursor a little bit to the left of this point, it's like dropping the left-hand side car. So there's my left bound car. See how that's going to stay put? Now I want right bound, which is a little bit to the right of that point. So I hit enter, and then I hit enter again, and it's going to converge on the solution, which is 1.2247 blah, blah, blah. Not easily factorable.
That's a 1 point. That's
That's
one.
one critical value.
Okay.
Now help me find the others, guys.
So you would go to trace, second trace. You would go to 0.
Mm-hmm.
And then if you want the guy right in the middle, you're gonna do left bound here.
It's going to be a little above it, right? Okay.
Oh snap! Okay, didn't let me.
Right bound is going to be where? A little below it,
Okay.
because it's a little to the right of it. And then we converge, and that x value, that critical value is 0.
Which is this guy right here?
That guy right there.
Okay.
Yep. And now we're going to do it a third time. This gets really old. But it's still faster than trying to factor this. So left bound, again, I want to be a little bit to the left of that point, so the cursor's going to be below it this time. Right bound, cursor's going to be a little above it. Guess, and it converges to the solution. So I have 3 critical values here. How do I test them to decide what they are?
Plug them in.
Using calculus. Plug them in where?
The second derivative.
And if the result is a negative, is it a max, a min, or a point
It's
of
a sad
inflection?
face, so that's a max.
Max, right? It's given in the shape of it. There's a max sitting right on top of that. If the answer is positive, is it a max, a min, or a point of inflection?
It's a min.
If the answer is 0, is it a max, min, or point of inflection?
Yeah.
Good.